Hi friends, welcome to my channel. In this next videos, we shall look at the principles of programming PIC microcontrollers, using the C language. C is one of the most popular programming languages used today, and there are several C compilers available for the PIC microcontrollers. We shall look at how to program the PIC microcontrollers, using one of the popular C compilers, known as the CCS compiler, developed by the Custom Computer Services. CCS C Compiler was selected for this tutorials, principally because it has an extensive library of peripheral driver routines. However, several other suitable compilers are available. The purpose of an embedded program is to read in data or control inputs, process them, and operate the outputs as required. Input from parallel, serial, and analog ports are held in the file registers for temporary storage and processing, and the results are output later on as data or a signal. The program for processing the data usually contains repetitive loops and conditional branching, which depends on an input or calculated value. Most programs need to process data in some way, and named variables are needed to hold their values. The variable name and type must be declared at the start of the program block, so that the compiler can allocate a corresponding set of locations. Generally, C integers are stored as 16-bit values, but C for 8-bit microcontrollers uses a default 8-bit integer format. In this program, an 8-bit variable x is declared, and assigned a value 99 using the equals operator. It is then output to port D, using the standard output function. Most real-time applications need to execute continuously until the processor is turned off or reset. Therefore, the program generally jumps back at the end to repeat the main control loop. In C, this can be implemented as a while loop. Condition for continuing to repeat the block between the while braces is contained in the parentheses following the while keyword. The block is executed if the value or result of the expression in the parentheses is not 0. In this case, it is 1. Which means the condition is always true, and the loop repeats endlessly. Within the loop, the value of x is incremented. The output therefore appears to count up in binary when executing. When it reaches the maximum for an 8-bit count, 255, it rolls over to 0 and starts again. Example to illustrate basic decision making is to change an output depending on the state of an input. A circuit for this is shown like this. A switch generates an input at RC0, and RD0 provides the test output. Common keyword for selection in many high-level languages is if. This program has the usual endless while loop, but contains a statement to switch off port T initially. The input state is read within the loop, using the bit read function input. This assigns the input value 1 or 0 to the variable x. The value is then tested in the if statement, and the output set accordingly. Note that the test uses a double equals to differentiate it from the assignment operator, used in the previous statement. The effect of the program is to switch on the output, if the input is high. The switch needs to be closed before running to see this effect. The LED cannot be switched off again until the program is restarted. The program can be simplified by combining the input function with the condition statement as follows. Conditional sequence can also be selected by a while condition. In this program, the input is tested in the loop condition statement, and the output flashed on and off. While the switch is open, that means input high. If the switch is closed, the flash loop is not executed and the LED is switched off. The program also demonstrates the delay function. If this were absent, the loop would execute in just a few microseconds. Since each machine code instruction takes 4 microseconds, at a clock rate of 1 MHz, the flashing of the output would be invisible. The delay required, in milliseconds, is given as the function parameter, and a reference to the function library is provided at the start of the program with the use directive. This allows the compiler to find the library routine delay _milliseconds. The clock speed of the target processor must be given in the use directive, so that the correct delay is calculated within the function. To avoid overrunning the video, we will continue with the PIC basics in the next video. Thank you for watching. Please do not forget to like the video, if you like it, and subscribe to my channel to stay up to date.